Hello everyone. In this video I am going to explain a simple technique to draw textures onto a skeletal mesh inside Unreal Engine. Now there are several tutorials on the subject already, however I found that no one really describes the technique to draw with an actual texture. Currently available plugins rely on some hacky and slow C++ code just to extract the UVs. The CPU-based method is less performant as it requires downloading the texture from the GPU, iterating each pixel. Also, this doubles your memory usage because now you store your texture in two locations. Other methods rely on additional draw calls, which may cost you valuable rendering time. So in this video tutorial, I explain a method that entirely relies on a GPU, doesn't require any C++ code, and can be done only with blueprints. Basically, we are going to use a slightly modified version of a technique called world-aligned UVs. But instead of projecting our texture in world-aligned axes, we are going to project it on our custom-defined axis. Our axis is defined by two variables, an origin position and our normal direction. Of course, the downside of this technique is that our texture may bleed onto the other side of the mesh or cause stretching on the edges. However, if you're looking to create some kind of bullet impact effect, this might be a perfect way for you to achieve that. Breaking this technique down to 4 steps. First of all, we are going to create a texture render target for each one of our skeletal meshes. Then we will unwrap our mesh. Then we are going to project our custom texture to the mesh and draw it to the render target. Finally, we are going to use the render texture in our material to blend between the wound and skin layers. So let's get started with understanding how the projection method works and then move on to the implementation inside Unreal Engine. I believe you are already aware that the UVs of a texture are basically just 2D coordinates between 0 to 1 as seen on this picture. We can easily calculate the UVs from the world space position by only taking the X and Y coordinates. We also have to translate and rotate the input coordinates so we can position our projection anywhere on our target surface. Finally, we will normalize the results to a 0 to 1 range to get our final UV coordinates. So let's have a look and see how we can set this up inside Unreal Engine 4. So we are inside Unreal Engine now. We're gonna go ahead with the first person template and we're gonna call this Mesh Paint. We're creating a new project, and once it's finished creating the project, we are going to add our character model since the mannequin character is not really suitable for this kind of technique. The reason behind is that the mannequin has overlapping UVs, and this technique requires that you do not have overlapping UVs on your character model. This is purely how the unwrapping works. So let's add this adventure character to our project. And once it's finished, let's start creating our render targets, our first step. So let's go to our content browser and create a new folder, Mesh Paint. And inside, we're going to create 2 render targets. Our first render target, we're going to call it CRT Unwrap. We are going to store our unwrapped texture over here. Let's make this slightly larger texture. You could make it smaller if you want to. I'm going to make it 4K so our model doesn't have any seams, and because the model also is using 4K textures, so since it's 4K I want to keep it the same resolution. For the address X and Y, set it to clamp. And our render target format, we're going to set this to RGBA32 float, so we have enough space to store our world position. Our next render target is gonna be our actual mask. We're gonna call it CRT damage mask, and we can make it smaller because we don't need all the detail. We're gonna keep it as it is. We're only gonna change the clamping to the address to clamp. With this setup, now we're gonna go ahead and set up our materials. First of all, we're going to go to our character material and set up our mask. We're going to blend between the base color, the skin layer to our mask. So we're gonna add a texture parameter 2D. We're gonna call this damage texture. Add the lerp. We're gonna use the alpha channel, but since we are rendering with alpha composite, we have to flip it, so we're going to use 1-. Hook this up to base color, and let's set our texture to CRT damage mask. So this is the damage mask we're going to use, and once we draw something on this, it's going to show up on the skin layer. Let's apply. Now our next material is going to be our Unwrap material. So let's create our Unwrap material, Unwrap. And in here we're basically going to take the UV coordinates and unwrap them so they're gonna be flattened out on this surface. So let's start building our graph. Texture coordinate. We're going to use constant bias scale to center our UVs. 0.5 to 1. And also let's add some notes so we don't have to dig into the material to find out what are the values. Let's multiply this by our texture scale. We're going to use scalar parameter, texture scale, or texture size. We were using a 4K texture, so we're going to call the value of this thing 4096. And because it's a 2D coordinate, we want to turn it into a 3D coordinate, so we're going to call append vector, which adds a z-axis to this value. So we're going to call it a constant, and it's going to be 0. Next thing is going to be actor position. So add actor position. So we're going to move this thing where our camera is, and then we're going to subtract from our current position. World position. Hook it up to world position offset, and let's duplicate this and excluding material shader offsets. Hook this up to emissive color, and now we should see something like this. We need to make a couple more changes to the material itself. Since we do not need lighting or anything else, we can turn this off, making it unlit. Also, make sure it's two-sided, so if we have flip normals, the UV is going to be unwrapped correctly. One more thing, since we're storing world position offset on the surface, we need to enable negative normals on the material. Also make sure we have skeletal mesh usage enabled. And looks like our job here is done. Let's apply and save. Our next material is going to be the actual material to render our texture onto the skeletal mesh. We're going to call this paint texture. So here we're going to grab our unwrapped texture. We're going to call the texture coordinates first, and we're going to say texture sample parameter 2D. We're going to call this unwrap texture, And let's find our unwrap texture here. We're going to subtract it from our position. Let's move to the beginning because it's going to be a little bit long graph. So we grab we need two parameters, of course, vector parameter. This is going to be our position, and this is going to be our normal. Now we have to rotate our position to this normal. So let's first of all make sure our normal is facing the right direction. So we're going to flip it. Constant vector free. We only have to flip it on the x and y coordinates since we're not going to use the z axis. It's only required for the rotation. We're going to call rotate vector. This is the look at vector, and this goes into the vector to rotate. The next thing, we're going to only take the x and y coordinates from our world position, and we're going to scale it down. This allows us to scale our texture in a world space. And our next step is to position our UVs to the center. With that done, we're going to scale our UVs. We're going to call this brush scale. Let's set it to 8. And the next thing is to allow to rotate our UVs in the UV space. Custom rotator. Now you can see the rotation angle takes a scalar value between 0 to 1. However, I would prefer to use degrees, so I'm going to use a little bit of math. Duplicate this and call this brush rotation. We're going to divide this with 360. So now we can set our value between 0 to 360 degrees. And let's clamp this down to 0 to 1 just to be sure. Now we have our UVs rotated, scaled and centered. Next thing is to clamp our UVs down so we don't have stretching texture. And finally, we're going to take our brush texture. Let's call this brush texture. And we're going to hook this to our emissive color. Now, to prevent our texture to bleed through the mesh, we're going to use a sphere mask. So let's grab our unwrap texture, duplicate, also grab our position and duplicate. We're going to create a sphere mask node, and we need 2 more scalar values. The first value will be our mask radius. Let's set it to 30. And our hardness. This basically controls how far away we're going to mask our texture and how is the fade out. Let's set this to 0.79. That looks like a reasonable value. And then finally, we're going to take our right channel from this texture and multiply with our sphere mask and hook it up to opacity. So our graph is complete. Now what we need to do is set a couple of parameters on our material. Let's make sure it can be used with skeletal meshes. Also make sure we're using alpha composite and we are using unlit. Apply and save. Now with our material set up, our next step is to set up our blueprints. So let's create a new actor and let's call it BP Painted Mesh. In this blueprint, first of all, we're going to go to Begin Play and clear our render target, so when we start the game, our mask is going to be empty. Clear render target 2D. Select our mask. Make sure alpha is set to 1. And here we need two functions. One function is to unwrap our mesh, and the second is to actually paint on our mesh. The paint function is taking two parameters. Both of them are vector. The first parameter is our position. The second parameter is our normal. Let's add a skeletal mesh component to our actor and find our character model. Set up the collision. Since we're going to use a line trace, we don't need anything else other than visibility, so let's set this to custom and make sure we only have visibility enabled. Also make sure collision is actually enabled. Next thing is we need a scene capture. This scene capture component is basically going to unwrap our model. So set the projection type to orthographic and the width to the same size as our unwrapped texture. So in this case it's 1496. Let's scroll down and select our texture target as our unwrap render target. Make sure we select primitive render mode to use show on the list, and turn off every frame and every capture movement. Now with this done, let's go back to our unwrap function and start building our unwrap functionality. Let's grab our scene capture component, and since we want to unwrap this character horizontally, we need to rotate the camera 90 degrees on the Y and Z axis. So set the world rotation, -90, -90. And next we are going to set the show only list to show only components. Show only component. And we are going to hook this up to our skeletal mesh. Now to unwrap our model, we need to set the material to our unwrap material. Let me show you how this actually looks like. So this is the unwrapped model. This is what we want to see, but to achieve this look, we want to only do it for this scene capture. So an easy way to do this is just to swap the material for a brief second, capture the scene, and then set our material back to the original values. So I'm going to reset the material, and what I'm going to do is I'm going to save the current materials to a local variable. Promote to local variable. We're going to call this TMP materials. And then Set material. We're going to use our Unwrap material. Then we are going to capture our scene. And then following that, we're going to take our previous materials we just saved and set everything back to its original value. Set material, material to material, index to index. So that's pretty much it to unwrap our model. Now let's go on to the paint feature. So before I build this, I want to actually start with the first person blueprint, so we can actually make sure what we built so far actually works. So here I'm just going to add a simple debug draw debug arrow, and we're going to do some vector math to calculate our arrow positions. Let's set this to 50 and just draw this arrow for a brief second. Thickness to 1, arrow size to 1. Let's compile and save. So let's go to our first person blueprint. And in here I'm going to delete everything basically. I'm only going to leave input action fires, so when we are actually firing with the weapon, we can do a line trace. Now line trace position gonna be our camera location. We're going to grab world location, and we need to trace forward from the camera. So we're going to get forward vector, get forward vector, multiply by a large scalar value and add it to our world position. So once we hit something, we want to actually get our actor to hit, and if it's the BP painted mesh, we are just going to call the paint function. Now the position is going to be our impact point, and the normal is going to be the impact normal. So now, if we grab our mesh paint character into the world, and we click play, we should see our normals being rendered with the debug draw. So as you can see, the projection is flipped, so we already set this up in a material, so our normal are gonna be flipped, and now we just have to actually render something onto the mesh. So let's go to our BP painted mesh, our paint function, and before we paint, call the Unwrap function, and then let's create a dynamic material instance. This is going to be our paint material. We're going to hook this up to our set vector parameter. We need 2 of these. Our first parameter we're going to set is going to be the position, and the second is going to be our normal. Let's hook up our position and normal parameters. Let's get these things out of the way for a second. And then finally, we're going to call draw material to render target. Now, this is the material we're going to draw with, and our render target is going to be our damage mask. So if we did everything right, and then we jump into the game, we should see that we are actually drawing on the mesh, but something is going wrong. So let's see what is actually happening. I believe I forgot to select the correct texture here, which is the case. So I'm going to select damage mask. Oh, I didn't actually import the mask texture, so let's go ahead and import our texture. And assign this texture, so this is the texture we're going to render with. So now we can actually draw onto our model. I can duplicate this, set an animation, so now we can draw on a model that is being animated. And it works. I hope you can reproduce it and you have a good time with this technique. See you next time.